Hello, and welcome to the Energy Sandwich family. I am Ruben, but you can call me Lux. In our project, we want to make it possible to make recycled energy from our steps. Our hypothesis is that when stepped on, the sensors will react to the movement by sending energy signals to whatever we are trying to send energy to. For example, turning on a LED light.
The design is the following. Two plates stuck together divided by bottle caps, in which they will be containing the sensors. The name, Energy Sandwich, is given since it visually looks like sandwich, since the two plates are together with contents inside.
Basically, the function of the sandwich is to restore an amount of energy that we use when we take a step and to use it for other purposes as electric energy. The way it functions is very simple as well as its structure. It's composed of two halves, each of them having a wooden base with a foam layer attached to it. For the actual mechanism, we use piezoelectric sensors, which are a kind of sensor that uses pressure to generate a signal.
So our hypothesis is that if we add more weight to the energy sandwich, then the voltage produced will be higher.
In order to make a more accurate mathematical model, we decided to change the independent variables. Instead of being the quantity of piezo units, now it will be the weight we will apply. And depending on the weight, we hope that the voltage will change, and that will be our dependent variable. Okay, so now we're going to use a multimeter to make the measurements, and yeah. So, how to use a multimeter? We're going to connect the cables right here. This is a positive, this is a negative. We're going to turn it on, and then set it to alternate current, and now we're going to leave it at this. So, as my partner just explained, how this works is that the current will pass from the pressure that it will apply in each piezo unit, and all of the energy will be accumulated and will end up in this sense. So now we're gonna measure it. We're gonna put the positive with the positive and the negative with the negative. Okay, so now my partner will put the other piece of wood on top, and we'll make pressure. We want to use different weights. First, 5 pounds.
These are the measurements. Okay.
Now we're gonna use 10 pounds. Okay, now we're gonna use 20 pounds. And then we're gonna use the 30 pounds.
As previously mentioned in the video, we changed the independent variable to create a more accurate mathematical model. Now, instead of having the independent variable be the amount of piezoelectric units that we're using, it's changed so that it is the amount of weight applied to the mechanism. The dependent variable, being the voltage generated, stays the same. The first thing we did to create this mathematical model was to turn the collected data into coordinates, with mass in pounds being x and the voltage in volts being y. Since there's room for human error while we were measuring, I decided to create two graphs, one with the collected data and another one with a linear equation that should give us a more accurate reading as to what the results that would be expected on average. The first thing we did to create this equation was get the slope. So we used the coordinates 5 pounds and 1.94 volts, 15 pounds and 8.69 volts. We now use an equation to get the slope, which results in 0.675, and from then on we use a point slope equation to get a slope-intercept form equation, which we will use to get a new set of coordinates with the estimated values of voltage that will be created on average.